Hey guys, we're going to go ahead and finish up 11.6 for today. We're going to look at something called a binomial experiment. And what a binomial experiment is it consists of n independent trials, and every outcome is either a success or a failure. So it's what you want to happen or what you wanted did not happen, so they consider it a failure. The probability of success, they call that P. It is the same for each trial. So things like flipping heads. If you want heads when you're flipping a coin, your success, the probability would be 0.5 or 1/2, because every single time you flip a coin, it is the same for every trial. You have 1/2 a chance of getting heads. The probability of failure, which they're calling Q, is the same for each trial. So same thing. If your success was flipping heads, and that was 1/2 every time, that means if you don't get heads, they would call that the failure. Well, the chance that you would not get heads is also 1/2. It's the same for every single trial. So they're trying to tell you that as you're doing these different trials, your probabilities stay consistent, because only two things can happen. It's either a success or it's a failure. They are complements of one another. And what that means is if you take P plus Q, your probability of success, plus your probability of failure, you have to get 1. Here are some examples just to kind of make sure that we're understanding before we jump into this. Let's say your experiment is that you want to flip coins. You want heads. Okay, so heads is going to be the success. If you don't get heads, then what's going to happen? Well, you're going to get tails. The probability of getting heads is 0.5. The chance of not getting heads is 0.5. So those are your success and failure probabilities. Let's say your experiment talks about rolling a number cube. You want to roll a 3. So that means rolling a 3 is success. Rolling any other number would be a failure because it's not what you're looking for. It's not that 3. Your probability of success, the chance of getting a 3, is 1 out of the 6 sides. The failure would be rolling any other number, 5 out of the 6. So that's kind of how they're going to go ahead and set this up. Now, when they first started studying binomial distributions, they had different scenarios, and we're going to go through one of those. The cool thing is by going through so many scenarios, they were able to come up with a formula that we will be able to use today. It will kind of keep it a little bit easier for us. But here's a scenario just to kind of show you how this works. Suppose that the probability of being left-handed is 0.1. That means the probability of not being left-handed would be 0.9. You want to find the probability that 2 out of 3 people will be left-handed. So that's our combination. How many total people? 3. You want 2 to be left-handed. Okay, so if you were doing a sample space or looking at all those different options, you could have left, left, and right, right, then a left, right, left, and left. Don't worry, you don't have to do this. The formula, what it's going to do is allow us to skip all of the steps where you have to write out every single possible option, like we had to when we were rolling 2 number cubes. They're going to give us a formula we can use to do this, okay? But what happened here is they took those scenarios and said, okay, well, if you want 2 of the people to be left-handed, the chance is 0.1. Remember, you multiply your probabilities together. So left-handed times not left-handed. Okay, and so by looking at different things like this, they were able to take this apart step by step, kind of dissect it in a way, and come up with a formula that you can use for binomial probability. Remember, binomial means that there's only 2 options. Your 2 options are success or failure. Did you get what you want or did you not? Here is how it starts off. You always start off with a combination. What is the total number of trials? And R, how many successes do you get? Then it's P. Remember, P is the success. What is the probability of success? To the exponent of how many times was the experiment a success. Q, what is the probability of failure? Your exponent will be how many trials minus how many successes, meaning the exponent is going to represent how many times did you have a failure in that experiment. So again, it's a combination times the probability of success to the exponent of how many times was it successful, times the probability of failure to the exponent of, well, how many times did it not work out so well? We're going to look at two basic ones, and we're going to step it up, okay? So let's talk about Jean, and Jean is doing some free throws. Jean usually makes half of her free throws in basketball. So P is success. I don't know about you, but I'd call the success when she makes the free throws. She makes half of them. So the probability of her making her free throws is 0.5. That means the success or the probability of failure, remember if you add success plus failure, it has to equal 1. So that too would be 0.5. So Jean has a 1/2 or 0.5% of making her free throws. And in turn, she also has 0.5 or 1/2 chance of not making her free throws. These are the two things we need in order to use this formula. Now let's keep reading. Today, she tries 3 free throws. What is the probability that Jean will make exactly 1? So that helps us with our combination. So we have 3. That's how many free throws she's going to make. We want to know the chance of her making exactly 1. Her success rate is 0.5. We want her to be successful on 1 of those free throws. Her failure probability is 0.5. If she makes 1 of the free throws, that means she failed at 2 of them. Now we have to calculate these things. Remember when you're doing a combination, it's outside number as a factorial over inside number as a factorial, and I usually call that R, there you go, and outside minus inside. That's what the formula was. If the outside is N, you have the outside as a factorial, the inside they had it as an R, so the inside goes as a factorial on the bottom, and the bottom is also outside minus inside as a factorial. So if I'm calculating a combination where I'm selecting 1 out of 3, it's 3 factorial over 1 factorial. 3 minus 1 is 2 factorial. And back to 11.1. 3 factorial is 3 times 2 times 1. 1 factorial is just a 1. 2 factorial is 2 times 1. Well, the 2 and the 1 would both cancel, leaving me 3 over 1. So my combination has a value of 3. 0.5 to the power of 1 is 0.5. 0.5 squared is 0.25. So your probability of Jean making exactly 1 of 3, you take 3 times 0.5 times 0.25, and you would get 0.375. So it's 37.5% chance that if Jean grabs a basketball, goes and makes 3, or goes and shoots 3 free throws, that exactly 1 of them will go in. Let's try another one just to make sure we've got it. Then we're going to go ahead and step it up. This is kind of fun. Okay, let's say we have a really big school, so we actually have 3 counselors. Okay, so rather than having 1 counselor when you enroll in school, there are 3 options. Okay, there's the scenario. Students are assigned randomly to 1 of 3 guidance counselors. That means every student has a counselor that they can go see if they have questions about school. What is the probability that Counselor Kraska will get 2 of the next 3 students assigned? So our success is getting Counselor Kraska because that's what we're looking for. Well, there are 3 guidance counselors. So the chance of getting Kraska would be 1 out of the 3 because there's 1 Kraska out of 3 guidance counselors. Failure would be what happens if we're not getting Kraska, because we're looking to get Counselor Kraska. So the chance that you won't is 2 out of 3 because there are 2 counselors out of the 3 that are not Kraska. So success, getting Counselor Kraska. Failure, not getting Counselor Kraska. If you add the 2 together, you'd have 3 over 3, which equals 1. And again, you always want your success and your failure together to add up to 1. Now here's your combination. What is the probability that Counselor Kraska will get 2 of the next 3 students? So there are 3 students. What's the chance that Kraska will be assigned 2 of them? Okay. Then it's your success. The success is 1 out of 3. They're saying out of the 3 students, Kraska will get 2. The chance that they will not get Kraska is 2/3. Well, if there's 3 new students and 2 get Kraska, that means 1 will not. Now this time I'm going to go ahead and work through it as fractions. You can do either one. You can do decimals or fractions. The previous example I did decimals, so this one I'm going to go ahead and work with fractions. Let's find the value of our combination. Outside is a factorial on the top, inside on the bottom, then outside minus inside. 3 minus 2 is 1. So it's 3 times 2 times 1. 2 times 1 and 1. 2 cancels 2, 1 cancels 1. 3 over 1 is a 3. Now, if I take the fraction, remember, if you square a fraction, you're actually squaring the top and the bottom. So 1 squared is 1. 3 squared is 9. 2/3 to the power of 1 is 2/3. When you are multiplying fractions, this is where you can cross cancel. So by going this way, I can cancel this 3 with this 3 because I'm multiplying by a denominator. Top times top, I would have 2. Bottom times bottom, 1 times 9 is 9. So I would have 2 over 9. If I go ahead and I divide them, 2 divided by 9 is 0.22. So there would be a 22% chance that in that school, if there were 3 counselors, if there were 3 new students, 22% chance that exactly 2 of those students would be assigned to Counselor Kraska. Okay, now we're going to go ahead and step it up. So you'll see that we only have one more example. This one is wild, but it's super fun, okay? So we have Ellen, and Ellen is taking a multiple choice quiz, and the quiz has 5 questions on it. It says with 4 answer choices for each question. So every question, let's say it's A, B, C, and D. There are 4 answer choices. What is the probability that she will get at least 2 answers correct by guessing? So let's say Ellen was supposed to read something and Ellen didn't. So Ellen went to English and there was a multiple choice quiz just to make sure that she read. There were 5 questions. Everyone had A, B, C, or D. We want to know what is the probability that she will get at least 2 answers correct. At least means 2 or more. So we have to do this process quite a few times and add our probabilities together in order to answer this. Okay, so let's go ahead and think about this step by step. Probability of success. Well, being a success would be to guess the answer correct. If there are 4 answer choices, the chance that you're going to guess without having any knowledge, the chance that you're going to guess it correctly is 25% because 1 out of 4. Your success of failure, your probability of failure would be the chance that you weren't successful. You guessed the wrong solution. So 3 out of the 4 answers are incorrect. Okay, so again, you're guessing. There are 4 answer choices. 1 out of 4 would be correct. That would be your success. 1 out of 4 is 0.25 if we're looking at this as decimals. Your chance of failure, meaning you don't get it correct. Well, 3 out of the 4 options are going to be incorrect. 3 out of 4 is a decimal is 0.75. Now we're looking at 2 or more answers. So we have to start at 2. So if there are 5 questions and you want 2 correct, your chance of guessing it correct is 25%. If you get 2 correct, then that means incorrect, you would have 3. So again, how I set this up. There are 5 total questions. This would be getting 2 correct. Your probability of success is 0.25. You're getting 2 of the questions correct. Probability of failure is 0.75. If you get 2 correct, that means you get 3 wrong. So I have to go ahead and calculate this. So my 5 combination where I have my 2, 5 factorial over 2 factorial. 5 minus 2 is 3. So it's 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Well, the 3, the 2, and the 1 cancel. 5 times 4 is 20. 2 times 1 is 2. So the combination is 10. If I go 0.25 and I square it, I get 0.0625. If I have 0.75 to the power of 3, 0.421875. So this would tell you your chance of getting exactly 2 right. I'd multiply them all together. So 10 times 0.0625 times 421,875. Your chance of getting exactly 2 right, and I'm going to go ahead and approximate this because if you're doing this with me, your calculator has a lot of numbers on it, okay? So we just have to realize that we are making an approximation. So approximately 26367. Now that is the chance of getting 2. Well, it says 2 or more. Well, if you got 3 right, that would be more than 2. So now I do the same process. If there are 5 questions, what's the probability that I'm going to get exactly 3 right? Well, if you're guessing, your chance of guessing it correct is 0.25. What happens if we get 3 of them right? That means that we would get 2 of them wrong. So we go ahead and calculate that. So I would have 5 factorial over 3 factorial. 5 minus 3 is 2 factorial. If you look at these two things, you can see that they're going to be identical. They both have a 5 factorial on the top, a 3 and a 2 on the bottom. So we know it's going to end up being 20 over 2. So again, this is a 10. If I take 0.25 to the power of 3, 0.25 to the power of 3, 0.015625, 0.75 squared. The reason why it's squared is because I'm getting 2 answers incorrect. If I go ahead and calculate that, 0.5625. So now when I multiply these together, what it represents is out of the 5 questions, what is the probability that I'm going to get 3 of them right? So 10 times 0.015625 times 0.5625. If I multiply those, I have 0.0, and again, I'm estimating this. I'm going to put that approximate symbol, 0.08789. So this is the chance of getting 3 questions right. This was the chance of getting 2 questions right. And look at how much this dropped. This is about a 26% chance that you're going to get 2 right, just guessing. Your chance of getting 3, it drops down to like about 9%. They say 2 or more, so I have to keep going. Well, what's the chance of getting 4 of them? Man, you'd have to be super lucky. So there's 5 questions. What's the chance of getting 4? Your chance of guessing is 0.25. We're saying, hey, you're going to get 25, or you're going to get that chance of success, that 0.25. You're going to get 4 of the questions right. That means your 0.75, that's a chance of failure. If you get 4 right, that means you're only going to get 1 wrong. So 5 factorial over 4 factorial, 5 minus 4 is 1 factorial. So I'm calculating that value. So it is 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and I have that 1. Cancel, 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 cancel. 5 over 1 is 5. Now I'm going to go ahead, 0.25, my chance of success, to the power of 4, because we're saying that we guessed 4 answers correct. So 0.0039 is how I'm going to round that. 0.75 to the power of 1 is 0.75. When I multiply this, that's my probability of guessing 4 out of the 5 questions right. 5 times 0.0039 times 0.75. I have 0.014625. So your chance, if you are just guessing, your chance of getting 4 questions right out of the 5, you guys, it's like 1.5%. As you can see, as we're saying that you're getting more correct, the chances of that happening are getting less and less. We have 1 more to go because it says 2 or more. It says that you're getting at least 2 answers correct. Well, this is 2, this is 3, this is 4. So now I have to say, okay, what is the chance that you're going to not read your assignment and you're going to go ahead and take that quiz and get all 5 right? If you're guessing, your chance of success is 0.25. We're saying that you're going to get them all right, all 5 questions. So your chance of failure is 75% because you're just guessing and 3 of the answers out of the 4 are wrong. If you get all 5 right, that means you're going to get 0 of them wrong, okay? 5 factorial over 5 factorial. 5 minus 5 is 0 factorial. 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Remember, 0 factorial, back from 11.1, that has a value of 1. Well, if you notice, everything's crossing off here. When everything crosses off, it's a 1. So if you have 5 things to select from, and in this case it's test questions, and you want 5 of them right, that combination has a value of 1. 0.25 to the power of 5. Holy smokes. 0.0009765, so I'm going to go 977. 0.75 to the power 0. Anything to the power of 0 is 1. So when you multiply them, it's 0.000977. That is your chance. If you are taking a multiple choice quiz with 5 questions and you're totally guessing out of the 4 answers that you're going to get them all right. Boom, boom. Remember, you'd have to move that decimal. Not even 0.1% chance. Kind of crazy. So now in order to answer their big question, we're talking about Ellen. What is the probability that she will get at least 2 answers right? What that means is 2 or more. So we have to add the probability of getting 2 correct, the probability of getting 3, the probability of getting 4, and the probability of getting 5. You add those together, and that gives you the probability that she will get at least 2, meaning 2 or more right. So 0.26367 plus 0.08789 plus 0.014625 plus 0.000977. And again, I'm going to do my big approximate symbol here. We had to round throughout this, okay? So it is an approximate answer. 0.367162. So it is approximately 36.7%. Now that's crazy when you think about it. It is just a little bit more than a third chance that she's going to get 2, 3, 4, or 5 right. That means there's about 2/3 chance that she's going to get 0 or 1 right because she did not read the assignment and she was just guessing. So right here, make sure when you are told to read or you have a quiz coming up that you do study, because if you're guessing, your chances of getting them right are not too high. And guys, this ends 11.6. I hope today's lesson was kind of fun. I do kind of like this type of problem. Your assignment today is just a few questions out of the book. You're going to go to page 840 and 841. Check out number 6 and 7. Jump ahead, go to 13, 14, and then 21 to 24. Hope you guys are having a great day, and I hope you enjoyed our lesson. Talk to you soon. Bye-bye.